So in this problem, you're going to use data to figure out the empirical formula. The compound consists of potassium and oxygen, and you have the amount of each. And we're going to use those masses convert to moles. So it's going to go mass to moles, and then we're going to look at the simplest whole number ratio between those moles. So let's start with potassium. We have 242.4 grams in the compound. We need to know how many moles that is. So we're going to look at our wonderful periodic table. And we know that 1 mole has a mass of 39.1 grams, and that's potassium. So when you do the conversions here, you get 6.20 moles, and that's potassium. And then oxygen, you start with the 49.6 grams that are in the compound. We want to convert to moles. So 1 mole of oxygen has a molar mass of 16 grams. That's oxygen. And then you do the math, and you end up with 3.10 moles. So this is a mole ratio, but it's not a whole number mole ratio. So what we want to do is write those values down here as subscripts, and then we're going to tweak them in a minute. But K 6.20 and then oxygen 3.10. Now again, if we want to get the simplest whole number ratio, we divide through by the smallest. So divide through by 6.10, that turns into 1. And then over here we divide by 3.10, that turns into 2. That's a whole number ratio, 2 to 1. So we can rewrite this as K2O. So you're not always going to get 1-to-1 ratios when you end up converting to moles. You always take those values, divide through by the smallest, and that'll get you the simplest whole number ratio, otherwise known as your empirical formula.